It is a matter of common experience with all of us that whenever any object is released in space, always it falls vertically downward. It appears that Earth attracts these bodies. So welcome student to my next video tutorial. Today we are going to discuss an interesting topic called gravitation, right? So you see, in our universe every object attracts each other. Incidentally, this Newton, that is Isaac Newton, also observed an apple falling from a tree. So all these questions we will be getting answered today, right? For what is this, why the apple is falling down, and what is the difference between gravity and gravitation. So all these things we will be come across. So first you see, what is the universal law of gravitation? So according to this law, the force of attraction between two bodies is directly proportional to the product of two masses and inversely proportional to the square of distance between them. Let us consider there are two bodies, right? Let us consider one is M1 and one is M2. Two bodies, they are separated by a distance. Let us consider that distance is to be R. Okay, so there will be a force on M1 due to M2. There will be a force on M2 due to M1. That means we can write, that means force on 2 due to 1, and this is force on 1 due to 2. Means both the forces are attracting each other. So this is a vital or important property of a gravitational force, is that forces are attractive in nature, right? Because masses cannot be negative. Okay, so masses are always a positive quantity, and there will be a force of attraction between two bodies. Now you see, the force between two bodies is directly proportional to product of two masses, and the force between two bodies is inversely proportional to square of distance between them. That means if the distance between the two masses is less, then force of gravitation will be more, and if the masses are heavy, if the big masses are coming closer to each other, then also the gravitational force will be more. So that means gravitational force depends upon, you see, product of the masses and distance between the masses. So if we combine these two, so we will be getting directly proportional to M1 M2 by R square, right? So or F equals to G M1 M2 by R square. This G is considered as gravitational constant. Okay, so according to the law of gravitation, the force of attraction between two bodies is directly proportional to the product of the masses of two bodies and inversely proportional to the square of distance between them. That is F equals to G M1 M2 by R square. So gravitational constant. So gravitational force, that is universal law of gravitation, states that force between two objects is directly proportional to product of two masses and inversely proportional to the square of distance between them. Now when the proportionality sign goes, we get a constant of proportionality, that is called gravitational constant. Okay, so what is the definition of gravitational constant? So when we will get cross multiplied, we will be getting capital G equals to F into R square divided by M1 M2, just cross multiplying. Okay, we got this expression. Now in order to define this gravitational constant, let us consider there were two masses. Two masses are unit mass. That means let us consider maybe they are 1 gram or 1 kg, or the distance between them is 1 meter or 1 centimeter, right? So if we consider this M1 also 1 gram and M2 1 gram, and the distance between them is 1 centimeter. Now if we substitute all the values here, then we will be getting F equals to F into 1 square 1 into 1. That means ultimately we will be getting F, that is G equals to F, right? So this one we have defined here. So gravitational constant is defined as the magnitude of the force of attraction. That is gravitational force or gravitational constant is defined as the magnitude of force of attraction between two bodies, each of unit mass, means both are 1 gram and are separated by a unit distance. That means the distance between the two masses is also 1 centimeter. So likewise we can find the SI unit and CGS unit of capital G, right? So what will be the SI unit? So SI unit will be, now capital G equals to force, the SI unit of force we know, that is Newton. R squared, that means meter square, divided by m1 into m2, that means kg into kg, that means kg square. Now if it comes up, then we will be getting Newton per kg meter square, right? So this is the SI unit. But if we need to find the CGS unit, so CGS unit will be so G was F into R square m1 into m2, right? So CGS unit of capital G will be F. CGS unit is dyne, this will be centimeter square, and this will be gram square, right? So dyne per gram square centimeter square. So the value of capital G is 6.67 into 10 to the power minus 11 Newton per kg square. So this value is fixed, right? So these are the units of gravitational constant in SI unit and CGS unit. So in the screen you can see I have noted down the properties of gravitational force. So what are the properties, what are the characteristics of gravitational force? That means how we can differentiate a gravitational force from other force that can be differentiated in this way. Like gravitational force, these are the forces of attraction. That means gravitational force, you see, that is due to the masses. Masses are always positive, masses cannot be negative, right? And there is always an attractive force between the two masses in the universe. So gravitational force is said to be a force of attraction. Next, they form an action-reaction pair. That means whenever two bodies are attracting each other, the force of attraction, the magnitude of the force remains same, but they act in opposite direction, right? So that is, the forces exerted by two bodies on each other are equal in magnitude but opposite in direction. Third point, these are central forces. That is, they act along the line joining the center of two bodies. That means whenever we consider the two bodies, they are attracting each other, always the force of attraction is calculated from center to center, right? Two bodies are attracting to each other, so the distance between two bodies is calculated from center of one body to the center of other body. Therefore, gravitational force is said to be a central force because the force acts along the line joining the center of two masses. Next, they are completely independent of the presence of other bodies in the intervening medium. So you see, there is an attraction between Sun and our planet Earth. So our planet Earth is revolving around the Sun, but it doesn't mean that we don't have other planets there. So we have the other planets. The other planets will also be having a gravitational force with Sun, but it doesn't matter or the presence of other bodies, right? So gravitational force between two bodies is independent of the presence of other bodies near them, right? So these are the properties of gravitational force. So what is the difference between small g and capital G? Capital G we have seen, it is called gravitational constant, and whereas small g is the acceleration due to gravity, right? So you see, in Newton's law of gravitation, there is a force of attraction between two bodies, right? But if out of two bodies, if one of the body is Earth, then we say that gravitation to be as gravity. I repeat, in Newton's law of gravitation, there is a force of attraction between two bodies. Let us consider m1 and m2. Now, both the bodies are attracting each other in equal and opposite direction, but out of the two bodies, m1 and m2, if we consider either m1 or m2, one of them is Earth, then we say that force of attraction between that two bodies is called gravity, right? So what is gravity here? In Newton's law of gravitation, the gravitation is the force of attraction acting between any two bodies, right? Between any two bodies there is a force of attraction, then we say there is an applicable law of Newton's law of gravitation. But in case if one of the bodies is Earth, then the gravitation is called gravity. So what is gravity? Gravity is the force by which Earth attracts a body towards its center. So whenever you throw an object, our Earth is attracting that object, then we say that that is due to gravity. And how we can say what an object is falling from a height, right, and it is in increasing velocity, so it will be having an acceleration, so that acceleration is said to be as acceleration due to gravity. So acceleration due to gravity, that is denoted by small g. Remember, gravitational constant is denoted by capital G, where acceleration due to gravity is denoted by small g, is the rate of increase of velocity of a body falling freely towards the earth. So whenever any object is falling from a certain height, its velocity always increases. So that remains constant, that is we will come to know that is 9.8 meter per second square. Okay, so this is acceleration due to gravity. So what is the SI unit of acceleration due to gravity? We will be using in numerical, that is meter per second square. So you see, now if we want to find the relation between small g and capital G, right? So let us consider this is a sphere of earth, right? An object is at the surface. Let us consider the distance between this small mass and the heavier mass. Let us consider this is mass of earth and this is mass of object, right? And the distance between two mass is capital R. This distance is, let us consider to be as capital R. Now the object weight is acting downward, that is weight, and there is a force of attraction between this big earth and small mass, so force is also attracting there. That means gravitational force is directly proportional to weight of the object, right? So gravitational force equals to weight equals to mg, that means mass of object, and this gravitational force we know that capital G, mass of earth, mass of object by r square, right? Now mass of object and mass of object will get cancelled. Now if we cross multiply, we will be getting G equals to small g r square total divided by mass of earth. That means this is the relation between capital G and small g. So capital G equals to G r square by mass of earth. So you see, I have substituted the value of all the terms here. You see, the relation between capital G and small g we have seen, that is capital G equals to small g r square by me, that is mass of earth. But if we need to find the mass of earth by substituting all the values of acceleration due to gravity, distance between the earth and the object, and gravitational constant. So small g value just now I told that is 9.8 meter per second square, and r square generally we take it as 64,000 kilometer, but here we have taken 6.38 into 10 to the power 6, right? So r square, that means r square means capital R value whole square and capital G value here. Now after calculation it has been seen that mass of earth is 5.98 into 10 to the power 24 kg, right? So this is the mass of earth. So similarly we can find its density also by the formula. We know density is equal to mass by volume, or mass can be written as density into volume, right? So density to be remaining as it is, that means 4 by 3 pi r cube. This is mass. So this was mass of the object, right? Now we are going to find the density. So mass equals to density into volume. So we know this is a sphere and volume of the sphere is what? 4 by 3 pi r cube. And what is the relation between small g and capital G? You see here, capital G or small g so in place of capital M we will be substituting rho 4 by 3 pi r cube by r square, right? So you see this r square and r will get cancelled. So if we cross multiply, then we will be getting rho equals to G by capital G pi r. Now if we substitute all the values here, again we will be getting the density, right? So we don't have to find this one, just for the derivation you keep it in mind. So we can find the mass of earth also, we can find the density also. But the main relation which we have to remember, that is relation between small g and capital G, right? So what is the relation between gravitational constant and gravity? That is capital G equals to G r square by me. And what is capital G? Capital G is called a gravitational constant, and whereas small g is the acceleration due to gravity. And out of two bodies in the Newton's law of gravitational uh, definition, out of two bodies, if one of the body is earth, then we consider the force to be as gravity, right? So these all things you need to keep it in mind. So let us see solve numericals. So it will be easy for us to understand the concept of gravitation. See, we have one question. Find the force of gravitational constant or gravitational attraction between two neutrons whose centers are 10 to the power minus 12 meter apart. Given capital J equals to 6.67 into 10 to the power minus 11 Newton meter square per kg square, right? And mass of Newton is also given. So you see, in this question we have to find force of gravitation. Mass of two bodies are also given. Here bodies are the neutron, and distance between both the neutron is also given here. So m1 and m2 given here are, that is distance is also given, and capital G, this is value is fixed, that means this one we have to memorize it, and it is also given in the question. Sometimes it is not given, right? So we have to remember this value. So we know the formula F equals to G m1 m2 by r square. Substituting all the values here, we will be getting this answer. Now the main thing is the calculation, you see. So how we are going to calculate here? First we are going to multiply without the power of 10, right? So first we will multiply the power without of 10, then we will be using the concept of exponent, which we have learned in class 8. So if the denominator power is negative, then it will go up, then it will become positive. Similarly, if the numerator power is negative, then when it will come in denominator, it will become positive. So likewise we will be solving, and we will get the answer in terms of 10 only, that is 10 to the power minus 40, right? And points should be after one digit. So this is how we calculate for the numericals of gravitation. Next question, you see, two planets of masses 10 to the power 22 kg and 10 to the power 24 kg are separated by a distance of 12 meter. Find force of attraction between them. Same formula by the law of gravitation, F equals to G m1 m2 by r square. Substituting the value of capital G, 6.67 10 to the power minus 11, and here 10 to the power 22, 10 to the power 24, and distance is also given here, 10 to the power 12. So we'll substitute now. 2 12s are 24, and here you see 22 plus 24, this will get added, then we will be getting here 46. Now 46, 10 to the power 46 and 10 to the power minus 11, so 46 minus 11, you will be getting here 35. Now 35 minus 24, this will be coming up, that means minus 24. So 10 to the power 35 minus 24, then we will be getting here 11, and rest answer will be remaining same, okay? So this is how we solve the numericals. So these are the few numericals you will be trying yourself, at least up to question number 1 2 3 4, right? 4 questions you will be trying as a homework. So in class 7 and 8 also we have learned across these questions difference between mass and weight. We know mass is a scalar quantity where weight is a vector quantity. Mass is same everywhere, it remains constant wherever the body is taken, but whereas weight depends upon small g, that is acceleration due to gravity, right? So mass is measured by beam balance, whereas weight is measured by spring balance. So these are the differences between mass and weight. So this also you need to write in your copy. Write the characteristic of mass and characteristic of weight, or you can write differentiate between mass and weight. So in the screen you can see this is the common balance, that is the beam balance, which is used to measure the mass, because as it is a scalar quantity, it does not depends upon the direction, but whereas weight depends upon direction because it varies with the value of acceleration due to gravity. Yeah, this is the spring balance, which is used to measure the weight of an object. So in this video only this much, so see you in next video. and prepare for the next online test. All the best.